Hello. So in part one, we covered up to this section, right? Summarize temperature values in a table using general statistics as table. So we are through it here. So here's part two. In part two, we continue from step six. Identify tree canopy coverage. So the second input variable in your heat risk index is tree canopy coverage. To be derived from a layer, the tree canopy data must be isolated and the amount of coverage for the area calculated. The formula is shown again. Land surface temperature plus tree canopy coverage plus population density is equals to heat risk index. Okay, you will add an ArcGIS living atlas layer that shows the global land cover categorized as 11 different land cover classes, including tree cover. You will use the tree cover class to isolate the cells in the raster layer classified as tree cover, which will be used to calculate tree canopy coverage. This step, you identify tree canopy coverage from an ArcGIS Living Atlas layer. Turn off the average surface temps Athens.stif layer. Then from ArcGIS Living Atlas, add the European Space Agency World Cover 2021 Land Cover layer. So just go ahead and do that. Say we should turn you off for here too. We can just do this back to catalog pane, portals here, and then I'll just click on this ArcGIS Living Atlas. Okay, now I can just paste that in and I'll hit enter. So here is the result. So can right click on it and then add to current map. Okay, so let's hold on, let that add. Alright, so the layer is loaded. You can see it here. So let's go back to the instructions. So the tree cover class includes all geographic areas that are dominated by trees with a cover of 10% or more. By adding this layer, you can already see that most of Athens and its surrounding area is dominated by the built-up class, which is symbolized in red on the map. The built-up class includes land that is covered by buildings, roads, and other human-made structures, such as railroads. Both residential and industrial buildings are included in this class. You will isolate the cells in your study area using a raster function. Raster functions are operations that apply processing directly to the cells of imagery and raster datasets. With the raster function, you can decide whether to only apply an operation to the dataset or to create a new layer, like a geoprocessing tool, WOLD. The remap raster function allows you to group cell values and then assign the group a new value. You will use the remap raster function to calculate the lack of tree canopy. So on the ribbon, click the imagery tab, and in the analysis group, click raster function. So let's just quickly do that. You say click on imagery tab, and then raster functions. If you are not seeing it, let me just do this. Okay, now you're seeing raster functions here. So I've clicked on it. Let it open. So the raster functions pane, scroll down and expand reclass. Okay, so let's do that. Let's collapse this. Look for reclass. Where are you? Expand reclass and click on remap. Right, that should be it. Click remap to open the remap raster function. Sorry, the item page of the land cover class indicates that tree cover cells have a value of 10. You remap the values in the layer so that tree cover cells have a value of 1 and everything else has a value of 0. The remap raster function output will display as a new layer in the contents pane. In the remap properties pane for raster, choose European Space Agency World Cover 2021 land cover. Okay, if this is for raster, let's choose that. So let's go raster, let's go European space, and then we have done that. For remap definition type, confirm that list is selected. Yes, list is selected. Complete the remap table using the following table as guide. Minimum 10, maximum 11, output 1. Okay, minimum 10, maximum 11, output 1. Okay, minimum 11. Okay, minimum 11, maximum 101. 101, output is 0, right? Leave the no data boxes unchecked. Okay, so max values to no data. Okay, so I should leave you unchecked. No problem, no problem. We are good. So click create new layer. Okay, we're gonna do that. Create new layer, and then new layer is added to the context pane that symbolizes three cover cells as 1 and everything else as 0. Turn off the European Space Agency world, blah blah blah. Save your project. You have added land cover data for ArcGIS Living Atlas and use it to identify tree canopy coverage. That's all for now. Let's go to step 7. Just in case, let me just show you the items page for this European Space Agency for the year 2021. Okay, let's look at it here. Classes 10 is tree cover, 20 shrubland, this as it. So this is the reference. This class includes any geographic area dominated by trees with cover of 10% or more. Other land cover classes can be present below the canopy, even with the density higher than trees. Alright, so this is just what we need to look at. Okay, so next we'll go to the next. This is step 7. So the European Space Agency World Cover 2021 land cover layer that you added covers the entire globe. Therefore, the output of your remap raster function includes tree canopy coverage for the entire globe as well. In this step, you will create a new tree canopy coverage layer specific to your study area so that you can calculate only the amount of tree canopy coverage for Athens. First, you will define your study area by creating a copy of the remap European Space Agency World Cover 2021 land cover layer using the Athens postcode layer as the extent. This will result in a layer that you can use to calculate tree canopy coverage for Athens only. Open the copy raster data management tool. Alright, so just come here, back to analysis, and then okay, the geoprocessing pane is already here, it's open. So let's just expand this up to this level, back to the geoprocessing pane, and then copy raster data management tool. So we are there. What's next? On the environment tab, set the processing extent to Athens postcode. So we need to quickly go to the environment tab. Okay, so click on environments, and then we come to the extend. Okay, extend of a layer, and then we are using our Athens postcode. Right, this that's what it said, right? Okay, good. On the parameters tab for input raster, choose the remap this. So input raster is the remap. Good. Okay, for output raster dataset, we are going to browse to the TIFF folder and we type in 3 canopy Athens .tiff. Okay, let's just copy this output. Let's hold on. Okay, here's the output. So just click on the folder here, click on folders, here is it. Okay, Control V, 3 canopy Athens.tiff, and click on OK. This is network issue, don't worry, we just do this again. tiff this, click on OK. Alright, so we have Okay, they say just click and run. Yeah, just leave the rest as default and click on run. That's the instruction. Okay. So turn off the remap. This, now that you have defined the study area for your tree cover data, you can use the zonal statistics as table tool to create a table with the count of number of tree cover cells in each postcode polygon. So we are going to open this zonal statistics as table, Spatial Analyst tool again. Okay, this tool is still running. Let's give it some time. Alright, the tool has finished running, so let's turn off the remap, and now we go. Tree canopy attends, you see. So let's click the back button and then general statistics as a table, uh, uh Spatial Analyst tool, right? That's what they chose. Yes. Also click on it, and then the present pane input raster official zone data is attends postcode, then unique identifier, blah blah blah. So we are doing almost exactly the same thing. Attend postcode, unique identifier, input value raster is the tree canopy attends. The output table is this, Ctrl V. Okay, is there another thing? Statistics type is sum. Okay, statistics type, scroll down to sum. That's good, and then we'll click on run. Okay, so that's done. We're going to save our project, and now let's look at the further instruction. You have created new layer for your second HRY input variable, tree canopy coverage. Using this new layer, you have calculated the amount of tree cover for each postcode in the attend study area. Alright, so the next step is step 8. Calculate tree canopy coverage as a percentage. So in an HROI, the tree canopy coverage input variable is presented as two percentages for the study area: percent tree cover and percent lacking tree cover. Now that you have a table that identifies the total number of tree cover cells in each postcode in your study area, you can calculate these two percentages. In this step, you calculate two percentage fields to finalize the tree canopy coverage input variable for your attention HROI. So on the ribbon, click on the table tab. Okay, so on the ribbon, we should click on the table tab. So I didn't understand that instruction, so I'll just come to here, count of tree, then go to open. Now yeah, I'll just click on the calculate field here. Where is it? Look at it, calculate field, and here for field name existing or new, we just put in this. Okay, copy and then paste it here. Then they said for field type, choose float 32-bit floating point. Float 32-bit floating point. And then they say for PCT tree cover is equals to enter this, that's sum divided by count times 100. Okay, let's go back here. Sorry, PCT tree cover. Let's copy it. We did not paste it here. Okay. Yep. click apply. So we'll click on apply. A new field PCT3 cover is added. The attribute table and shows %3 canopy coverage for each Athens postcode. We'll now calculate the percent lacking 3 canopy coverage for each postcode. In the calculate field dialog box for field name, delete this and type this. So we're going to just PCT lacking. Okay. Just here. PCT lacking. And then formula will say 100 minus PCT3 cover. Okay, so we're just gonna make it like so. Say click apply, then click OK to close the tool. So we just click on apply, click OK, and then you have calculated the %3 cover and the percent lacking 3 cover for each postcode in your Athens study area. Close the table and save your project. You are now done preparing second input variable for your ESRI 3 canopy coverage. So we are through with this second step. Okay, we should clap for ourselves. Look at the PCT lacking, and then the PCT3 cover and PCT lacking. So we have these values here. So we are through with this step, so we can save our map, and then we'll move to the next step. Step 9 is calculate population density. So the third input variable for your HRI is population density, which identifies the areas with the most people. This information will help the city prioritize densely populated areas in its adaptation plan. So back to the formula: land surface temperature plus 3 canopy coverage plus the third one, population density, is equals to heat risk index. In this step, you calculate population density for each postcode in Athens using Athens postcode layer. So they say turn off the 3 canopy Athens.tiv and open the Athens postcode attribute table. Okay, so we should turn you off, and then where is Athens postcode? Right click on it, and then attribute table. Okay, right, so we have opened the attribute table. It says the attribute table contains 2 fields that you can use to calculate population density. We have 2024 total population and area in square kilometers. Okay, these fields were already included in the grid postcodes boundary layer from ArcGIS Living Atlas that you use to create your study area. The formula for calculating population density is total population divided by area of polygon postcode in this case. Okay, so let's look at it. 2024 total population, area in square kilometers. Okay, no problem, we have it. You will use the 2024 total population and area in square kilometers field to create a new field in the attribute table that calculates population density. Open the calculate fields tool. For field name, type pop density. So this we can quickly do this, right? We can calculate, and then this is population density, and then for field type, choose float 32-bit floating point. So field type floats 32-bit floating point. And then for expression, from the field list, double click 2024 total population to add it to your expression. Okay, for expression, the field is double click this. Okay, there's expression 2024 total population. Okay, 24 total population. Oh, to the right of the insert values field, click the divide symbol. Okay, I can see it here. And then for the field, is double click area in square kilometers. So you're going to do that, area in square kilometers. Where are you? Yeah. Okay, click apply and then click OK. Save your project. Okay, so click on apply. Okay, so you can see it here, population density. You can see it has some values. So they say you have used the Athens postcode layer to calculate the third input variable for your area population density for each postcode in the study area. So save your project. I've done that. And step 4 is to combine the input variables. Yeah. So what we have done so far is just I'm working on the 3 input variables, which is land surface temperature, tree canopy coverage, and what they call it, population density. So now it's time to combine. So after the input variables have been prepared, they can be combined to create the HRI. Although you have derived the 3 input variables for your heat risk index, the data values are currently stored in 3 separate tables. You need to join the standalone tables to the Athens postcode layer. In this step, you will combine the 3 input variables to create the HRI for Athens. First, you will use the join field tool to transfer the PCT lacking field from the count of 3 cells table to the Athens postcode layer. Okay, so open the join field data management tool. So let's go join field, data management tools. Let's click on this view tab, then reset pins for geoprocessing. So join fields, data management tools. Okay, we have done that. So for input table, choose the Athens postcode. Input table, Athens postcode, and then for input fields, choose unique identifier. Okay, input field, unique identifier. For join table, choose the count of 3 cells. Okay, count of 3. Okay, for join field, choose ID. Okay, it's using the ID to identify the two. Alright, let me turn on this base map so it doesn't look somehow. Okay, you select the field. You will select the field in the count of 3 cells table that you want to transfer to the Athens postcode layer. For transfer field, choose PCT lacking. Transfer method, transfer fields, PCT lacking. They only mentioned one, so no problem. Click run. Okay. Okay, so we're only adding this PCT lacking, no problem. So let's click on run. Alright, so it has finished running. At the end of the Athens postcode attribute table, notice that the PCT lacking field has been added. Okay, let me just open it again. Shouldn't have even closed it. Right click and go to attribute table. It has been added now. What if I close it? Let me close all this abracadabra so I can see it. Okay, it has been added, no problem. Next, you will add the land surface temperature input variable to the Athens postcode attribute table. So join the high average temperature by postcode table using ID as join field and max as a transfer field. Max as a transfer field. So let me just go back to here, view tab, set for geoprocessing. This is exactly where it was, and we're changing the join table to the land surface temperature, right? Sorry, I'm confused. Next, you add a land surface temperature input variable to the attends. Where is it? Let me see it here. This is high average surface temperature, right? High average surface temperature. That's the join table. Where are you? High average surface temperature, join field. Using the ID as a join field, correct. ID is still correct. Let's see ID, and then and max as a transfer field. So you're transferring the max. Transfer field is max. Okay. Is there any other thing? No. Click run. So you are running this join field again. Okay, so the max field has been added to the attends postcode attribute table. The field represents the highest average surface temperature for each postcode. All three input variables that you derived for your HRY are now stored in the attends postcode attribute table. However, the input variables use different units of measurements and must be standardized before being combined. You will use the standardized field geoprocessing tool to standardize the units for the three input variables. So open the standardized fields data management tool. So let's go ahead and do that. Standardize. Copy. Then let's click on this back and then just data management tool. Okay. For input table, choose the attends postcode. Yeah, you this, and then you will use the minimum maximum standardization method to standardize the input variables and create a 5-point scale, with 1 representing areas with the lowest heat risk index and 5 representing areas with the highest heat risk index. So for standardization method, choose minimum maximum. So minimum to maximum, yes. For minimum value type 1, for maximum value type 5. Minimum value is 1, maximum value is 5. Okay. In the fields to standardize section for input fields, click the down arrow and check your 3 input variables. And here is also a hint: population density, PCT lacking, and max. Okay. Field to standardize, we have population density, PCT lacking, and max, and say add. Okay. For max, change output field name to high average temperatures mean to max. So okay, for max, output field name, let's delete that and put high average temperatures mean to max. This is still lacking mean to max. Okay, high average temperatures mean to max. Okay, that makes more sense. And then click run. So we're going to click on run. Okay, you have created 3 new fields in the attends postcode attribute table to standardize the input variables on a scale from 1 to 5. Your 3 input variables have now been combined to create an HROF attends, 1 representing areas with the lowest heat risk index and 5 representing areas with the highest heat risk index based on each input variable. So close the attribute table and save your project. Next, we're going to visualize the heat risk index. Okay. So we are through with the analysis. Like, let me just close here, and you can see it's the three new fields: population density min to max, PCT lacking min to max, high average temperatures min to max. So we are good to go. So we're going to step 11, visualize. So after the three input variables have been combined to create the HRI can be visualized on a map. To visualize the HRI for Athens, you need to adjust the Athens postcode symbology to reflect the standardized scale that you created. In this step, you will use an arcade expression to adjust the Athens postcode symbology to visualize the HRI for Athens. Arcade is a lightweight expression language used to create custom contents in ArcGIS applications like other expression languages. Arcade can perform mathematical calculations, format text or symbology, and evaluate logical statements. The Arcade language was designed for use solely within ArcGIS. Turn on the Athens postcode layer. Right-click Athens postcode and choose symbology to open the symbology pane. For primary symbology, click the down arrow and choose unclassed colors. So, turn on. Where are you? Athens postcode is already on here, and then just click here to open the symbology pane. Okay. Then you can go back here. You say for single symbology, you should click there and say what. For primary symbology, click the down arrow and choose on class colors. Primary symbology on class colors. Good. Next to fields, click the set an expression button. Okay. Click on set an expression button. Okay. You will use the expression builder tool to write an arcade expression that will symbolize a map of Athens based on a sum of the HRI values for each input variable. Okay. In the box below expression, delete the existing text. Okay. In the box below expression, delete the existing text. For functions, scroll down until you locate sum. Where are the functions? Here you are. QROST Ezekiel MONOP QROST. Okay, here it is. Okay, double click sum to add it to your expression. Double click. Okay, you will use this sum arcade function to sum the HRI values for the three input variables. The expression box after sum, click between the parentheses to continue writing your expression. From the field list, double click this. Okay. Population density min to max. So let's look at it. Good. Type a comma after the word max. Okay. From the field list, double click PCT lacking min to max. So I think this is just clear, straightforward. Comma PCT lacking. I think there will be a comma again, so let me now just go back there. Then high temp average. Again, comma after that. From the fields, high average temperature. So you have it like click OK to apply the expression. So you sum this plus this plus this. Click on OK, no problem. You now choose a color scheme that better visualizes the results. For color scheme, select yellow to orange to red continuous. color scheme, yellow to red to orange. Show names. Let me see. Yellow to orange to red. Let me see again. Yellow to orange to red continuous. Let me find you. Yellow to green to red. Let me look for you. Yellow to red. Yellow to orange to red continuous. Good, I found you. To make simulation easier to see on the map, you will change the visual effects of the Athens postcode layer. Wait, you gave a okay. On the button, click the visual layer tab and in the effects group set transparency to 10.10. Okay. The ribbon, click this transparency to 10%, right? 10.0, yeah. Let me view the results that they show here. Okay, let me see whether does our result match. Yes, it does. Thank you. Although transparency is a commonly used visual effect, ArcGIS Pro offers additional visual effects for layer and features such as blending modes. Layer blending draws the entire layer and blends it with the content underneath, such as a base map. Blending ensures that the labels on the base map remains visible. You will use the multiply layer blend effect. Q. Set transparency to 0. For layer blend, click the down arrow and choose multiply. Okay, it says set it back to 0. For layer blend, click and it said multiply, right? This. For layer blend, click the down arrow and choose multiply. Let me see. Okay, it's blending with the base map. Perfect. The final map symbolizes postcodes with higher HRA value in darker shades of red. These postcodes will benefit the most from the addition of 3. Postcodes with lower HRA values are symbolized in lighter shades of yellow and orange. Save your projects. You have used data from ArcGIS Living Atlas to derive three input variables to create a heat risk index for Athens, Greece. You have visualized your results on a map to highlight the postcodes that are hotter, have fewer trees to protect against extreme heat, and have more residents. The chief heat officer and the city of Athens can use the resulting intervention focus map as a planning tool to prioritize areas for tree planting. Seems like we are through with our analysis, right? We're through with our analysis, so it's time to share the results. Wow, let's clap. Now step 12, share your map. Okay, heat risk indices can be shared with stakeholders involved in implementing adaptation plans for extreme heat. Your map is ready for sharing with community leaders to help them prioritize the postcodes that will benefit most from tree planting. This step, you will share your HROI map to ArcGIS Online as a web map. The only layers that need to be included in the web map are the Athens postcode layers and the base maps, nothing more. Therefore, you remove the layers that you do not need before sharing. The contents all layers except the Athens postcode layer and the base map. Note, if you did not want to remove the layers, you could instead create a new map and copy and paste the Athens postcode layer to the new map. Okay, I think I'll go with that second option. Okay, I'll go with that second option. So let me pause this video and just do that. Okay, so I've removed everything except the Athens postcode and the base map. Okay, so they say you will adjust the map properties to allow assignment of unique numeric IDs for sharing web layers. This step will prevent warnings or errors when analyzing your map or sharing. So in the contents pane, right click map and choose properties. Okay, this is now map 1 properties, and then what else? On the general tab, check the box for allow assignment of unique numeric IDs. General tab, check the box for allow assignment of unique numeric IDs for sharing web layers. Okay, click apply and click OK. Apply and then OK. Share your web map as a web map using the following parameters: name, Athens, thesis underscore Francis Otia. Okay, so click on the sharing tab, web map, and then yeah. So here is name. Let's control V. Francis Otia. I can type it together. I don't care. Alright, summary. So for summary, put this 8 risk index for postcodes in Athens, Greece, and the surrounding urban areas. Okay. This, and then tags is Athens climate change, 8 risk. Okay, share with everyone, analysis of any error if necessary, and then share your map. So they said we should analyze, and then okay, everything is good, so click on share. Good. Okay, web map shared successfully. Okay, so you can click on the configuration. Okay, this is the map configuration. Messages. Okay, what am I supposed to do next? Let's click on manage the web map. Oh, sorry. You don't have I'm logged in with a different account here, so that's why you're having this. But no problem. We have shared it. You can update the sharing level to everyone. I think I can do that in the web. Alright, I think we'll end this here. We have tried. Back to here. Let's go. You have optional stretch goal. I'm not going this side. But in case you want to do it, here is what says ArcGIS allows you to enrich data with demographic variables like median age or household income through its geo-enrichment service. Enriching your data, you can add geographic context and insights to your data and enhance your spatial analysis. Walking through its spatial analysis, like um, creating a heat risk index, an iterative process. You can add more data, switch data, or even enrich your data to refine the analysis and gather more information about your study area. In this course, you have learned that vulnerable populations are disproportionately affected by climate change. With this in mind, in this stretch goal, you will be enriching the Athens postcode layer to incorporate vulnerable populations into your heat risk index. Generally, the populations that are most vulnerable to extreme heat are older adults, young children, unhoused people, and outdoor workers. So, identifying vulnerable populations while creating adaptation plans will result in more equitable solutions. You can use the form to ask other MOOC students for assistance when completing a stretch goal. Alright, thank you for now. We'll close now at this point. So, thanks for staying with me. Bye for now. Thank you, thank you, thank you.